So, yesterday, through that video, we talked about parallel and perpendicular lines. So, through the video yesterday, we should remember that parallel lines are two lines that they keep going the same, like the same distance, and that distance in between them is never changing. They're never getting closer to each other. They're never getting farther away. They're staying that constant rate apart from each other. And then we talked about perpendicular lines. So perpendicular lines were two lines that were not perpendicular. Two lines that, when they intersect, they form a right angle. So all of those angles in there make right angles. So these are two types of situations we have. Okay, so this is what we talked about yesterday. Along with that, we learned yesterday that parallel lines, if we look at the equation of both of those, or we look at the slope of both of these, parallel lines have the same slope. So if I have 2/3 as one of my slopes, 2/3 is going to be the slope of my other one. Parallel lines have the same exact slope. They were congruent slopes. That was something from yesterday. Perpendicular lines, though, they had reciprocal slopes. So 2/3 was my slope. My reciprocal slope was 3/2, and then we also changed the sign. So reciprocal doesn't necessarily always mean changing the sign, but with perpendicular, yes, we'll always. Good. Sorry. Yeah, so perpendicular, if we start at 2/3, we flip it upside down and then change the sign to -3/2. So that's what we talked about yesterday, maybe, correct? Okay. Another thing that was thrown in there is, given a graph, what was the slope of that line that's going to be formed, and how to graph it from that given point. I know you weren't able to practice this yesterday because you didn't have your practice worksheet, but we'll do a quick. So for finding the slope from a line, you need to pick 2 points on that line, and we need to find the slope. What's the rise and the rise? So I see my rise is -1. I'm going down, and then my run is 2. So that's -1 over 2. If I am looking for a line that is parallel, I'm going to use that same slope. So my parallel line will also have the slope of -1 over 2. So from my given point, I can go down 1 over 2, down 1 over 2, up 1, to the left 2. And that would be my parallel line. Graph through that point. Are we okay with that so far? Same thing with perpendicular. If we're looking for a perpendicular line, the only thing we have to remember, though, is that slope is going to change. It's going to flip and change signs. So if I start at -1/2, I need to flip that to 2 over 1. And if I'm a negative, I now become a positive. So 2 over 1, I'll start at that same point again. That means I go up 2 over 1, up 2 over 1, and keep going all over. So this is my perpendicular line to my given original. Once again, it'll be perpendicular to both of these because these are parallel. Are we okay with that from yesterday? So that's what we were supposed to get from yesterday. So good. We're going to add just another thing onto that. And you should have, this is where it should start. So we know how to graph them. Now what we want to do is be able to write the equation of the line. So if we remember from yesterday, linear equations have two things. They're always in the form y = mx plus b. One thing is that slope, that m. Every linear equation will always have a slope. That's one thing we need to know in order to write the linear equation. The other thing is the b, that y-intercept. So these are the two things we need to find our slope, or to find our equation of our line. So if we want to write the equation of the line, we need to figure out what is the slope of this line and what is the y-intercept. So those are some two things that keep in the back of your mind as we go through this problem. So we were asked to write the equation of a line that is parallel to the given line and goes through our given point. So just like what we did in the last problem, we want to graph a line that's parallel. So first things first, figure out what is the slope of this line. So if I start at -4, 0, or 0, -4, and then 1, -1, if I look at my rise and my run, that's a rise of 3 and a run of 1. I'm thinking this is parallel. Parallel, once again, always has the same slope, congruent slopes. That means my parallel line is going to have also 3 over 1. So from my given point, I can go up 3 over 1, just like I did. That's only 2. And this is my parallel line. Just like what we did on that last problem. The only thing else we need to do now is we need to write the equation. What was that?
Positive.
Yes, yes. Positive 3, positive 1. So I'm going in a positive. I have a positive slope. If it was negative, it'd be going down. So the only thing now that I need to do different is I need to write the equation of this line. Once again, we're writing y equals mx plus b. So I need to figure out what is my m and what is my b. Well, I already know my m is the same as my slope for my parallel line. So it's y equals 3x, or 3 over 1, whatever you prefer, same number. But I need to figure out what is that b. Remember, b is the y-intercept. The y-intercept, that's always where you cross the y-axis. Where do we cross the y-axis on this line? For our parallel line. So it's going to be 3, so that will be y equals 3x plus 3. Yeah, with this equation, we're always looking for the equation of the line being true, that new line we made. So we found the slope was 3 from our parallel line. And we saw we crossed the y-axis at 3, so y equals 3x plus 3 is our answer. Are we okay with that? Let's see another example.
For some reason, my line is unequated. I want to read up through.
From
Yeah.
up 3. So same idea on the second problem. First things first, we need to find the slope of our given line, because we know we're going to be parallel to that. So I need to pick 2 points. One right here, and one right here. And your points might be different from mine, but it's okay. They should still yield the same results. So if I look, that's negative 2. I'm going down 2 and over 3. So negative 2 over 3 is my slope. Once again, I want to make a line that's parallel to this. Because I'm parallel, I'm going to use that exact same slope, negative 2 over 3. So from my point, I can go down 2 over 3, but that'll take me off the graph. So I'm going to go backwards. I'm going to go up 2 to the left 3, up 2 to the left 3. And this will be a new line. They look parallel to each other, so that's good. That's what I wanted. Last thing, I just need to write the equation of this line. I know it's going to be y equals mx plus b. I know my m is already negative 2 over 3. So I have y equals negative 2/3 x. I need to figure out that b though. Where am I crossing my y-axis on this?
2.
2. I'm crossing it there at 2, so it's just going to be plus 2.
So you take the y-axis of the one you just drew.
Yes. Yeah, we're looking for the equation of this, the line we just drew, so we're going to take that y-axis.
Okay.
Are we okay with this? Okay, cool. So let's try this again. Is that rather than dealing with parallel lines, let's use perpendicular lines. Once again, perpendicular lines, unlike the parallel lines, rather than using that same slope, we're going to take the opposite reciprocal of it. But we still need to figure out what the slope is. So I can look at my line given, and I find 2 points. My rise of my run, that's a negative 3 and a 4. The negative 3 over 4 is my slope that was given to me from my line. But if I want to be perpendicular to this, I need to change it. Once again, perpendicular, we're going to flip it upside down and change the sign. So that makes 4/3, and it's going to be a positive, because my original was a negative.
Right, forward, negative.
So with perpendicular, we always want to change the sign as well. So I flip it, and it'll be 4 over negative 3, but I'm going to change that negative to a positive. So there's 2 steps. You flip it and change the sign. So we have our slope of our perpendicular line. Now we just need to graph it. So once again, that's up 4 over 3. So up 4 over 3 takes me off the graph. So I'm going to go down 4. 1, 2, 3, 4 over 3. 1, 2, 3. And then I can only put 2 lines on here, so that is my line. Not perfect, but you get the idea. So we graph the line. Last step, write the equation. Y equals my slope. I know my perpendicular slope is 4 over 3. So 4 over 3x plus my y-intercept. If I look, I cross my y-axis at -3. That means -3. That's the equation of my perpendicular line. We okay with this?
Mm-hmm.
All right, take a moment, see if you can do that last one.
Is this it? Like, is this what the test is gonna be?
There's one other thing we're gonna talk about.
I was gonna say, this is easy, we can take it.
So we should have gotten -1/4 for a slope. So it's y equals -1/4 x. When we look at, we cross the y-axis at 2. -1/4 x plus 2. Are we okay with this? All right, so there is one other thing. What happens if we don't have a graph?
You make it on
So you could draw a graph, but that could take a lot of work, and your lines might not be perfect and things like that.
Will you give us a ruler for this one?
No, you shouldn't need a ruler. You can draw lines.
Or you said they straight?
You should still be able to figure out where the y-axis is without it. You should be fine. All right. So what if we don't have a graph? So let's see how far we can get without the graph and see where we struggle. So same type of question. Write an equation of a line that passes through the point rather than drawing the point. They give it to us with -1, 2. That is parallel to y equals -4x plus 5.
Well, you can keep your, right, same.
I know I'm going to be parallel, so I know I'm going to keep y equals -4x. So I know that's going to be the same because of parallel lines. Yeah, -4 over 1, -4, same thing. The only thing we don't know, though, is that y-axis, that y-intercept. Sorry, it's a b. My 6's and my b's look so much alike. It's terrible. Yeah, Algebra 1 was like struggling for the past couple days. We've been doing this in Algebra 1, and yeah, they make fun of it all the time. All right, so y equals -4x plus b. We don't know what b is. We can't solve for it either, though, because we have an x and a y in the equation. Remember, in order to solve for a variable, you can't have any other variables in the problem. What can we do?
Could you put in the point
How?
2?
Like
Well, what's
add up the -4 over 1, add up the -1.
Let's think what this point is. So what is a coordinate point made of?
Oh, wait, it's a y coordinate.
An x and a y.
Take
So you just take the 2 from the y, and then, 4 times -1.
Yeah, we can substitute -1 in for x, and then 2 in for y, because -1 is our x, -2 is our y. We know our point will eventually cross that line, so we know this will work. And then we will have only b, so we can solve for it. So that means 2, and then -4 times -1 plus b. So whenever you're given your equation, like these, or given these problems, figure out what your slope is first. What is my slope? And that should be given to you from that original line you're told, and whether you're being parallel or perpendicular to it. That should be, you should be able to figure out the slope, just like on those last problems. Once you get there, substitute your points in for your x and y, and then solve for that b. So in order to solve, first things first, we're going to multiply. So -4 times -1, we multiply that together, we get 4. So we have 1, 2 here. So we have 2 equals 4 plus b. In order to solve for b, I just need to get rid of that 4, so I'm going to subtract 4. So 2 minus 4 is -2. That's my b.
That's easy.
Last step, just rewrite the equation with all our information. So we know it's going to be y equals -4x minus 2. And that is our parallel line.
This is easy.
Good on that?
Mhm.
Yeah. Let's look at a perpendicular one.
Oh,
So same strategy, same ideas, it's just perpendicular rather than parallel. So we're writing an equation on a line that's passing through point 47 that is perpendicular to the line y equals 2/3 x minus 1. So once again, we want to start with that slope. Our original slope of our line is 2/3 x. But if we want to be perpendicular, we need to change that 2/3 x to the perpendicular slope. So once again, I'm going to flip it upside down. So it's 3/2, but I also need to change the sign. So now I'm negative 3/2. So this is my perpendicular slope. So if I write my equation with what I have so far, I have y equals negative 3/2x plus b. In order to solve this, I need to substitute something in for my x and my y. So I know 4 is my x, 7 is my y, so I can throw those numbers in. So that makes it 7 equals negative 3/2 times 4 plus b. Are we okay with this so far? All right. First things multiply, then we need the inverse. Multiplying fractions. If you forget how to multiply fractions, it's either top by top, bottom by bottom. If it's just a single constant or a single number times a fraction, multiply by your numerator, divide by your denominator. So negative 3 times 4, negative 12, divided by 2 is 6. Negative 6. So we have negative 6 plus b, that equals 7. Last step to solve for b, inverse 6. So I get b equals 13. Final step, rewrite that equation with all my information. Y equals negative 3/2 x plus 13. Seems okay? See if you can do that last one on your own. If an equation of a line passing through the point 3, 1 is parallel to the line y equals 2/3 x minus 4.
4, 1.
All right, so your last thing you should have is y equals 2/3 x minus 1. It's parallel, so we're using that same 2/3. Substitute your 3 and your 1 in your equation. Solve for it, you should get negative 1 as your b. So then you rewrite it with y equals negative 2/3 x plus 1. Are we okay with this? All right, good. That's where we'll